It's a pleasure to meet everyone. Now, the previous efforts have introduced very wonderful. Now I bring the connect is universal computing power enables wireless intelligence. With the development of society and the evolution of technology, the concept of computing power is becoming more and more popular. Whether it is to C application scenario, to be industrial application, to edge cloud security, to NVR metaverse, and so on. They all need strong computing power as support. Similarly, the integration of CT and IT is getting closer and closer. In the future, it must be the architecture of a network. The computing power is a brain, and the network is a branch. The ubiquity of computing power must be the future evolution of communications. In communications, centralized computing based on data centers has its drawbacks. First of all, according to the data, in 2021, 50% of devices in the 50 billion IoT network will face network bandwidth restrictions. Secondly, due to storage capability limitations, 50% of the data cannot be analyzed, processed, and stored in the data center or cloud computing. In addition, more and more applications have harsh requirements on end-to-end delay. So we should consider some scenarios where computing power evolves towards a decentralized model driven by the Internet of Things and intelligence. A large amount of data will be generated at the edge in the future. So the business model should gradually shift from the network as the center to the service closer to the edge. Computing power, thinking deployment, computing power everywhere. In addition, centralization and decentralization coexist. Cloud and edge coexist is a trend to communication. We should give full play to the advantages of good network infrastructure. And on this basis, the low cost, large scale, rapid deployment of computing power capability. In this way, omnipresent computing can be deployed near massive communication facilities to support the incubation of various commercial application scenarios. In this mode, two typical application scenarios will first appear. One is the low latency application. For example, in machine vision and real-time speech, as shown in the figure. Another is the data security application. In demand to be, data can be installed on the internet of the industrial park, creating a low-cost deployment made in which data cannot be deployed outside the industrial park. We know that the industrial generally has a node of local business integration and swift deployment of private networks to meet the requirements of real-time business and short opening time and minimalist deployment of customers. So in the face of those demands, our computing base station comes in handy. Computing power base station is the explanation of AI computing power and storage capability, and the basis of the traditional base station communication surface. New capabilities such as computing surface and intelligent surface are added to combine various resources and computing resources to realize the collaborative integration of computing and network technologies. The application objects of computing power base stations mainly include production, enterprise customers who are cost sensitive, have swift deployment and one-station delivery requirements, especially local small and medium-sized industrial park customers. Centering on the three core contents of connection and computing power as a service. The goal is to provide the industrial with swift, low cost, simple, and capable one-stop solutions. The architecture of the base station is shown in the figure. Take CPU and memory and hard disk and other hardware computing power as the base. The BBU, VUPF, and RIC models are connected to provide local diversion service and low latency connections. Through less containerized base, PaaS platform, SaaS edge applications, and customers' capability components, open interface are provided to meet all kinds of different service. In the 2B, it promotes the architecture of computing and network integration, enabling intelligent and simple private network of closed network industry, such as digital workshop, closed loop production, and flexible production. In the 2C, make the wireless network intelligent, assist the optimization of wireless resource and air interface processing of 5G base stations, and improve the performance of the wireless network and the user experience. For the 2C customers, the computing power base station can meet the near real-time requirements of service or featured by developing the near RT rig, based on the advantage of nearby base station deployment and communication and computing hard solution with best pass function can ensure the increased computing power. On the one hand, the base station can select the best carrier for network for users to improve the business experience. It can also provide users with accurate scouting of airport resources such as beam to achieve the effort of intelligent interference. Correlation besides the power-based station can also adjust the energy saving period to ensure the best balance between energy and business experience. With the capability integration of local application, local computing and local streaming, big data computing, and wireless communication are both integrate and hard isolate. The performances of the base station is improved steadily under the condition of robustness. In terms of the architecture of computing power design, the hardware wireless computing power architecture of CPU and GPU and FPGA is adopted, which is modular and expandable, so that the AI can brought online quickly, and it has several calculations. First, It can be realized computing and communication decoupling, software and hardware decoupling, software online upgrade, enabling network performance and customized applications. Second, it can be flexible developed in the CU peer position to manage module communication nodes with fast computation convergence and accurate AI collaborations. Third, it realizes the computing network through XN interface can be expanded the demand and the capacity can be expanded. In the application of 2B, through the power base station and cloud edge cooperation and the AI version. The first is the video detection function of the data acquired and which can realize real-time detection of high-quality images of products through industrial high-definition cameras and transmit the data to the 5G power base station for intelligent detection and analysis. At the same time, real-time operations can be carried out according to the feedback results. Secondly, the collect data will be transferred to the edge computing terminal for AI inference local calculation. The image data uploaded by the transmission is based on the trained AI model for real-time analysis and decision making. And the data is analyzed and uploaded to the
Excuse me,
cloud.
please, what's your time?
Okay. The cloud platform will conduct AI training and the industrial cloud platform will receive the edge cloud data information analyzation. The vehicle road comparison scheme based on intelligent transportation is mainly applied to complex things of mixed vehicles such as standard intersections in irregular multiple intersections and ramps. Real-time data is correlated by roadside cameras and LiDAR sensors on the side of the road. Target identification and tracing on traffic patterns are carried out by machine vision, deep learning, and other algorithms in the edge computing community. The mobile communication network provides low delay and high trust perception data to assist intelligence networked vehicles to improve driving safely and overall traffic efficiency. This is the end of my introduction. Thank you for your listening.